Now, as you know, we don't use calculators in this course, and that limits the types of questions that I can ask you in trigonometry. So we're going to rely on three important triangles. Some of you may choose to memorize these triangles. Others might memorize a table that I give you, or you might memorize more points on the unit circle. I don't really care which method you use, but you are going to have to memorize something. And what you're going to find as I'm teaching is that I always use the triangles. So let's start with an equilateral triangle. In an equilateral triangle, all of the sides are the same length and all of the angles are the same measure. So if we have 180 degrees in a triangle, that means they're all the same at 60 degrees. So the first thing I want to do with my my equilateral triangle here is draw in a perpendicular bisector. Perpendicular means I'm forming a 90-degree angle, and bisector means that I'm cutting this side in half and I'm cutting this angle in half. We're going to say that this triangle had a side length of 2, so now each of these is 1. I want to look at just this one side of that triangle. You can see that we have our base of 1 and our hypotenuse of 2, but we're missing a side length. Use the Pythagorean theorem to find that missing side. I hope you remember that the hypotenuse is always c. And you should have found that our missing side length is the square root of 3. Positive root 3, of course, because we have a triangle here. Now I want you to notice a couple of things. First of all, that this right angle is our biggest angle at 90 degrees. And our biggest angle is the opposite or across from our longest side. Our smallest angle, 30 degrees, is opposite our smallest side. So this is important. This is always true of every triangle because we want to take a look at this triangle now so that we can use it in answering some of our trigonometric questions. So let's fill in our triangle. We have 60 degrees here and 30 degrees here. Whenever we have this triangle of 30 degrees, 60 degrees, and 90 degrees, we're going to let the hypotenuse be 2, the longest side across from the biggest angle. We're going to let this side be 1, the shortest side across from the smallest angle, and that gives us square root of 3 here for B, for our missing side before. Now remember, we're saying that our initial side is always on the horizontal. And so this is going to be theta right here from the initial side to the terminal side. So theta is 60 degrees. We have our terminal side on the positive x-axis. So we see that x is equal to 1. We see that our vertical side is the side that corresponds to y. So we're going to say that y is the square root of 3. And r, the hypotenuse or radius, is 2. I want to take this same triangle now and tip it over so that this angle is 30 degrees and this angle is 60 degrees. Can you fill in the side lengths? It's still a 30, 60, 90 degree triangle. So our hypotenuse will be 2. Across from the smallest angle is our shortest side, and that across from 60 degrees, the square root of 3. Remember that we always measure our theta from the horizontal. So this time, theta is going to be 30 degrees. We see that x is the square root of 3. We see that our vertical side that corresponds to y is equal to 1, and r is still 2. We're going to use these triangles to help us evaluate sine, cosine, and tangent of 60 degrees and 30 degrees. I said at the start of this lecture that there were 3 important triangles. The third one is an isosceles right triangle. In an isosceles right triangle, we have 2 sides that are the same. And since one angle is already 90 degrees, and these 2 angles have to add up to 90 degrees, they are both going to be 45 degrees. If we let our side lengths that are equal be 1, can you find the missing side length? I hope you found that c was plus or minus the root of 2. Remember that our radius is always greater than 0, so positive root 2. Again, our horizontal side is corresponding to x. Our vertical side is corresponding to y. And then our hypotenuse is r, or the radius. In this triangle, we see that theta is 45 degrees. So every time theta is 45 degrees, we see that x is 1, y is 1, and r is root 2. Take a bit of time to start memorizing these triangles so that you're ready for the next lecture.